Now we have reached the end of our course, our Open HPI course about internet security. 6 weeks we worked together and looked in the different areas what's important in the context of internet security. And while our course was running, a number of new, very recent security incidents happened. So you saw this from the newspaper, you found it in the discussion in the media. So what we want to do is to have a short look back on the last 6 weeks and what was discussed in that. We cannot go into detail and we cannot mention each of the security incidents that happened, but we can shortly discuss some very important ones. So for example, all the media are discussing privacy issues around the Facebook and Cambridge Analytica scandal of the last days. During our course there was an important botnet attack. And botnet attack, a denial of service attack against GitHub. The role of GitHub is very important, so we will see some and we'll discuss some details about it. There were a number of ransomware attacks happened during the last week. In the field of mobile security, the stage fright vulnerabilities are still an issue. And we already discussed this in the next course. Hardware security was a problem. So we could not relax even though Meltdown and Spectre CPU vulnerability are patched. There are something going wrong in this area and we want to have a short view on it. Let's start with the Facebook and Cambridge Analytica scandal. What happened? 2015. Dr. Alexander Kogan proposes a Facebook app for personality prediction. His name was This Is Your Digital Life. And he did it to get data and to make investigations, analytics for psychological research. About 270 users gave consent that the app access their data. For example, access their data, their city, the content they liked, or even friends' information. So this app from Kogan could access and could collect this data. Particular issue was that the data of friends was also collected. The friends which opened their data to other friends but didn't give consent. So this data were also collected. So if as soon as their privacy setting allowed such an access. So overall data in that by this app was collected not only from the 270,000 users that gave their consent, but over this friends connection, there were data collected of around 50 million users. 50 million users, very private data about daily life. So this was the first problem, that these friends didn't give a consent for that kind of collection. Second big problem was that although only allowed for research, Kogan promised to use this data for psychological research, the data was passed from Kogan to a third party company like Cambridge Analytica. And then Cambridge Analytica did their own investigations. And what was found out, they misuse this data for political and governmental analytics all over the world. So there's a saying that they tried to infect by analyzing this data, and what the conclusion they could see, that they could very specially find out to which type of person, what kind of content should be sent. So there is a discussion that this company with their action, which were based on this analytics of this data from 50 million people, that they try to affect for example, elections. So what one has to have in mind, in any case, we mentioned it on different time and different situations in our course, is that it needs informed decision about what data you put on social networks, what you put on the internet, what you put in the media. So this is very important to carefully manage the privacy settings. Because data which are given to this social media, they are in other people's hand and can used, like this example show, by third parties. So there is a promise by the big, for example, Facebook and by the big platforms to use only the data for the purpose the platform promises. But in reality, there are often situations that data hand over for several reasons, to earn money, to make things happen, to third-party companies. The user does not know that her data come into the hand. Another very recent security incident was this denial of service attack against GitHub. Before I go into detail, let's shortly remind some things we discussed in the course. I hope you remind the notion DDoS, distributed denial of service attack. So a variety of attack sources are synchronized to run a denial of service attack in a way that a service is no more able to work in a correct way. So there is not break-in, there is from many points a request of a service so that the service provider, the machines of the service provider are no more able to provide the service in a correct way. So the goal of such denial of service attack is to terminate the right functionality of the service. Another attack we discussed in detail was IP address spoofing. IP address spoofing, you remember, an attacker posing as a trusted sender generates and sends data packets with a faked IP address. A faked IP address typically from his or her victim, so that the people or the firewall do not work like they work if the data comes from an external unknown person. And then the amplification attack I have to mention to describe this GitHub DOS attack. The amplification attacks is, the goal of that attack is to increase the power of any attack with a relatively low effect. So if an attack has happened, then to amplify the attack to create bigger damage or others. Usually this is done via exploiting a specific vulnerability or exploiting properties of a protocol or software to increase the impact of the attack. These three things, denial of service attack, IP address spoofing, amplification attack, that was mixed together for this GitHub attack we want to discuss. Before I'm able to explain this, I have also what's called Memcached. Memcached is an open source software to give a system faster access to data that are frequently used, for example, website data. Usually this Memcached is run behind a firewall and is not reachable via public internet. UDP, this is beside of TCP, a protocol on the transport layer, and compared to TCP, UDP is very lightweight, is connection-less protocol, and is unsecure. So for example, there is no sender-receiver handshake in the beginning and in the end to establish and to finalize a connection. UDP provides no guarantee the data is delivered And now I'm able to describe this GitHub DOS attack. There was an amplification attack. The attacker finds that here in GitHub, it's publicly reachable mem-cached instances. This was a failure in the configuration of that instance. So the attacker requests large content with a small UDP package. So the attacker forges client IP address, this was the spoofing, and then requests with target IP of victim, and server will send responses to the victim. So memcached replies large content to the victim IP, and in this sense, the following attack were amplified. Some of you perhaps have nothing heard about GitHub. GitHub is really something very important. It's the world's largest community of developers with over 80 million repositories with typically open source code of software. So also open source systems, they place their code on that platform so that other developers can access this. And what happens? Just when our course was just started in February 28, GitHub was unavailable for a couple of minutes. It sounds not so bad, but due to this huge amount of systems that are placed on that platform, this couple of minutes hindered a huge number of developers to access this data, to access the code, to work with the code. So the attack, which was the reason that GitHub was unavailable for some minutes, was the denial of service attack from over 10,000 unique endpoints worldwide. So in the botnet, more than 10,000 computers start in the same second to access GitHub to do something there. Then the attacker used an amplification attack via a publicly reachable memcached instance I just described this to come in a situation that there was really a serious denial of service attack produced out of it. So the amplification factor was up to 51,000. So 10,000 unique endpoints, application factor 51,000. So you see it was a real important and heavy denial of service attack. So the situation when one byte was sent by the attacker by means of this amplification with a memcached system was 51 kilobyte which data that are sent to the sender. So at maximum 1.35 terabyte per second. That means 127 million packets were sent per second to GitHub. And under this heavy load, GitHub was no more able to provide the typical service to the community to give developers access to that service. So the mitigation, the routing to GitHub changed to identify and block attackers. This needs a while, but then in this way the attack was managed. Other attacks that run in the last weeks were ransom attack, which also find some public attention. What are effective protection against such ransomware? Ransomware we discussed in our course. Here are some more details how to protect against such ransomware. The first protection measure is to prevent infection itself. So you need to be always careful with email attached. Do not open it if you do not know what's in, if it comes from a person you do not know. But even if it comes from a person you know, it could be spoofed. So keep system updated to prevent infection while serving. This is for all kind of prevention. It is an important way to update systems so that with the update vulnerabilities are closed. Then, of course, use current antivirus software. It does not help in any case, but in any case it helps. Another effective protection method is to think about your data. So the idea of a ransomware attack is to encrypt your data, that you cannot more use the data, and then the attacker asks for money to decrypt it. If you have your data backed up, then there's no need to pay anything. Then you can delete all the encrypted data and can continue to work with the backup data. But of course, backup need to be done regularly. If you do it once a year, then you lost all the data of the last year, of the time to the last backup. So if the infection is successful, in case the infection is successful with such a ransomware malicious software, then system must be reinstalled completely. The data, the encrypted data are lost, and then you can take your data from the regular backups and start to work with it. What is important when we speak about backup, that the backup of the data should be done on an external media. An external media that's connected to your system in the moment you back up data. But then, if you are finished, then you should disconnect this external media from your system. So if your system got infected, then this external media, which is not connected, cannot be infected. So connect, if you do it with an USB hard disk, then connect this device for backup only, 4 times the backup, and then disconnect it. One can also use special software when backing up network shares. But also here, one should not permanently embed share as network drive, otherwise infection can also affect this. Discussing about ransomware, every time there is a discussion whether one should pay or whether one should not pay. So there is no comprehensive answer to this question. There are many, many different aspects that need to be considered, and also it needs to be make decisions case by case, considering the details. So, for example, the German government cybersecurity agency, that's the BSI, generally advises against payment. What's the reason? They say payment supports criminal business model. The data is not always decrypted despite payment. So there are cases known where the people paid to the criminals, but the criminals did not give the key for decrypting the data as they promised to do. Instead, take screenshots and report the incident to police, so that the police is able to find, try to find the attackers, to make it impossible in future that they attack systems. And then you should store any encrypted data for later decryption attempts. So if you have some more time, one can try to use also the script without keys, but generally this is difficult. So main argument is with the money you pay for decryption, you support criminal business models. But there were also cases known where the data has been decrypted after payment. So it's not a general rule that they asked for the money, cyber criminals asked for the money without later decrypting. So one does not know what happened. Here was a very public case. So a Los Angeles hospital paid $70,000 for decryption of their patient record. So by means of this ransomware attack, all the patient records were no more usable. And of course, this is terrible for a hospital, so they paid the requested amount to the attackers, and then the attacker decrypts the data. This also gives some hint that one should make decisions about paying or not paying dependent from the value of the decrypted data. If this value exceeds the extorted amount, then payment makes at least economically sense. But with a very good backup management, one can avoid to come in the situation to think about paying or not paying, because then one can delete all the encrypted data and restart system with the backup data. Next topic from recent incidents were in the world of mobile security. Some vulnerabilities were detected. You know, smartphones are run with operating systems, and in this way they are very similar to normal computers. And these operating systems, they have vulnerabilities, they have specific vulnerabilities. So modern smartphones are computers with adapted operating systems and specific applications. And these operating systems and applications come with vulnerabilities. So if we look to the most often used operating systems, then if you are using Android smartphone, then the operating system of an Android smartphone is based on Linux. And if you use an Apple iPhone, then the operating system of an Apple iPhone is based on macOS 10, an operating system from Apple. And as well, Linux as is macOS 10, there are a number of vulnerabilities known, which affect computers run with this operating system and which also affect smartphone versions. There were some spectacular cases, and in particular, this stage fright vulnerability was get public attendance. The Starthread is a library for viewing and processing videos and audios on Android systems. So the vulnerability in this Starthread library was around already in 2015, so many years ago. And the problem is it applies to about 1 billion Android phones. Phones from Android version 2.2 to 5.1. And then there was an exploit, which misuses this vulnerability. And this could be installed in a multimedia file, for example, in a video, in an audio file. And then the mobile phone receives, for example, a multimedia MS, and the default settings allow that it's automatically downloaded, and then if such a multimedia file with such an exploit is downloaded, then the exploit is automatically executed and the attacker can get full control of the cell phone and, for example, delete the MMS. So what is important? Switching off MMS reception. The difficulty here is that this does not work, as exploit can also be run with any other application that work with multimedia. So switching off MMS does not prevent that the exploit is run when, for example, you use a browser or you open an email or a Facebook app which allows such multimedia access. Then the original bug in this library, in the StateFridge library, was already fixed in 2015. But updates themselves were flawed. So that was a new update in August 2015. Then in October 2015, StateFridge 2.0 was released, a new library. But also in this new library, a number of critical Android vulnerabilities were detected in this 2.0 StateFridge library. These new vulnerabilities concern all the modern Android versions. So StateFridge vulnerabilities have been around for many years and still pose a persistent problem. So be very carefully with using multimedia, the multimedia files on your phone. So what are measures against StateFridge? Basically, every time install latest updates as soon as they are available. But we have a problem, particularly with many of the Android variants coming from different providers. We have discussed this already in other places. That's not so easy to apply an update to such an Android variant. So one needs to wait up to the moment that the provider of that variant adapts the update, so that's also applicable to this variant. So what needs to be done is to switch off automatic MMS reception in the messaging application settings. You should not use applications on Android mobiles and Android tablets, except the recent version of Firefox, if no current update has been installed. So remove all applications like email, Twitter, Facebook, and so on, which can process multimedia data from the internet, or refrain from using it. Of course, this is an advice. For many people, it's not acceptable. So if you cannot do without this application, then you should think to buy a new smartphone and switch to an updated version of Lineage operating system, which is not available for all systems. So change is on your own risk. So here, particularly for the older Android variants, the provider will not provide versions of the update because they do not support this smartphones. I want to finish this mentioning of the last recent security incident with a few remarks about hardware security. You remember, an operating system manages the computer hardware, CPU, memory, and controls how applications interact with the hardware of the computer. However, at the end, the program code, together with other programs, is executed on the hardware. So low-level access to the hardware allows an attacker to ignore all security mechanisms on the operating system level. So this is a goal to become below the operation system, and the operation system, of course, provides a lot of such security mechanisms. So what we heard about Intel and AMD CPUs, that they have an autonomous computer inside which runs even when main computer is turned off. It is needed to manage, to provide services to run the Intel management engine, for example, that could be used for remote management of the PC and for other activity. So a portion of the network traffic goes to Intel ME before the main operating system gets this data. And here comes a problem with the hardware vulnerabilities. Hardware vulnerabilities can be exploited to get such a low-level access to be able to bypass all the security mechanisms of the operating systems or of the applications. So what was happened in the last weeks? In January 2018, the hardware vulnerabilities Melton and Spectre in branch prediction mechanisms got a lot of attention in the media. This prediction mechanisms were used to reach a higher CPU performance. We have already discussed these vulnerabilities in detail in our excursion 2 of this week. But it's not only the Meltdown and Spectre which happened, which became obvious and discussed as CPU vulnerabilities in the last week. Also some other CPU vulnerabilities which were discussed and became public. So for example, in May 2017, the vulnerability in Intel Active Management Technology, which is based on the already mentioned Intel Management Engine, allows a network attacker to get full control over the computer. Since 2011, it affects many computers with Intel CPU. Another in November 2017, 2 more vulnerabilities were published. And then very recent in March 2018, vulnerabilities were published for AMD platform, Secure Processor. This is something which is analog to Intel ME, the management engine, and also these vulnerabilities provide attackers a possibility to bypass security mechanisms in the operating system and the software to directly get access to the hardware and the machine. So when we speak about hardware security, what can we do? What are measures against such CPU vulnerabilities? So first is stay updated. Some of these vulnerabilities can be repaired by software updates. A hardware update is difficult. By hardware update, you need a new processor or a new motherboard. So such updates every time can only work, can only be offered at the software level. However, updating operating system and software systems is not enough anymore. It is important, you should do this because some of these vulnerabilities can be fight against on the operating system level, but it's not enough anymore. Regularly check news, check advisories on your hardware which you are using, not only including CPU. This helps you to get informed about something. You should take care, and typically this publication also give advice what could be done. For example, in the case of Intel Active Management, Intel offers a tool to check for the vulnerability, whether your system is affected. Here is the URL of that tool provided by Intel. The motherboard manufacturers are responsible for providing updates, because it's their problem if data get damaged, if computation get damaged, computational resources get damaged because of that vulnerabilities. For some Intel CPUs, a number of tools or instructions are available to remove or to disable or to damage Intel ME. So this is also something one can use to protect systems against such hardware vulnerabilities. The removal can be technically very complicated. So often it's not possible to do by a non-professional person. There is also the problem and the danger that if one applies such tools, if one tries to repair such hardware vulnerabilities, that one damage the complete PC. So here you need to be careful, stay informed, and be very careful in using your systems so that you not become a victim of any kind of attack.